In this presentation, we'll be talking about AI and accessibility. I'll explain why accessibility isn't just a compliance checkbox. Artificial intelligence is everywhere. Creed's development teams are currently working on chatbots, enhanced search, GEO, and automated outreach tools. The question we need to be asking is, who are we building these tools for? Today, I'll show you why accessibility isn't just a compliance checkbox. It's a UX issue that will determine whether our AI projects succeed or fail. I'm approaching this from a user experience perspective, not a technical implementation standpoint. I'm not going to talk about ARIA labels or H1 headings. That's the expertise of our developers. I'm here to talk about what happens to actual users when AI accessibility fails, and how we can catch those issues before they become problems. The reality is, most AI projects fail, not because the technology is bad, but because the people who built them didn't understand the actual user problem. Accessibility issues are just user experience issues for users with specific needs. And AI is creating new UX problems faster than we're solving old ones. When AI works well, it can genuinely transform accessibility. Think about voice control for people who can't use traditional inputs, real-time captions at conversational speed, facial recognition that enables people with paralysis to control devices, document summaries for cognitive accessibility, image and scene descriptions that enable independent shopping, reading prescriptions, navigating spaces, adaptive search, and task assistance like automated alerts and doorbell notifications. These tools all succeed because they start with user needs, not technology capabilities. Here's an example of the promise of AI. AI can generate alt text so users with a loss of vision can access online content. But AI can also introduce unintended barriers and bias. A recent study of image recognition technology from Amazon, Google, and Microsoft found consistent gender bias in AI-generated descriptions. The AI used keywords like official and professional most often for images of men, while keywords like pretty and smile appeared most frequently for women. This matters because if the tools we're building use AI-generated metadata, we run the risk of baking in biased assumptions about our users. This is the central problem of AI. We can automate and speed up some processes, but we still need human input to address AI's gaps and correct its biases. A study measuring word information loss for non-native speakers across major automated speech recognition systems showed higher error rates for non-native speakers or speakers with accents. Another study documented 28% word error rates for non-native speakers versus only 6 to 12% for native speakers. A Washington Post investigation with Global Me Research tested smart speakers with Chinese, Indian, and Spanish accents and found about 80% accuracy versus much higher rates for English speakers. The problem goes much deeper. People with stutters, speech impediments, or conditions affecting speech clarity are completely unable to use some voice systems. This means they can't use AI voice assistants, phone systems, or automatic captioning. They're unable to benefit from the accessibility improvements these systems claim to offer. So a question we should be asking ourselves is, who is excluded? Not just inconvenienced, but actually excluded when this feature doesn't work. In another case study, blind screen reader users documented their experiences with AI chatbots across multiple websites. They found that one demo they were using worked perfectly with a mouse, but caused significant challenges for anyone using a screen reader. When they sent a message, the focus would jump back to the top of the page, meaning they'd need to navigate through the entire page again to continue the conversation. In another case, new messages weren't announced, so users didn't know when a response arrived. That defeats the goal of getting instant support. The last issue was especially problematic. Users found that the main content of the page occasionally bled into the chatbot, making it difficult to distinguish the conversation from the page content, and making the chatbot completely unusable. This kind of accessibility is non-negotiable for many of our clients. As businesses in insurance, medtech, and nonprofit sectors rush to try to implement chatbots, we need to help them ensure that they can meet a high standard of accessibility. So another question we need to ask: what happens when we only test the happy path? What do we miss when we fail to test the more challenging, but actually necessary user pathways? In this last case study, users found that the algorithm Netflix used to make recommendations didn't take into account data points, like whether closed captions were needed. It treated these fundamental accessibility needs as content preferences. That's not a minor accessibility issue. That's a fundamental UX failure. If someone needs captions in order to access content, the system shouldn't just use that information to narrow recommendations. It should ensure all recommendations have captions available. Users with disabilities are the edge cases that can reveal whether you actually understand the problem. In this case, Netflix failed to understand the actual user problem. So yeah, even the big guys get it wrong sometimes. Are we providing the information users actually need? Are we building search tools that help them find what they need, or what the AI thinks they should want? The UX lesson here is that AI projects fail because the people who built them didn't understand the actual user problem. In the examples above, the voice recognition software that only worked with standard speech meant the designers didn't understand the diversity of user input. The chatbot that only works with a mouse, not a screen reader, shows developers didn't understand how users actually navigate. The enhanced search recommendation algorithm that buried accessible alternatives revealed a business that didn't understand what users actually needed. AI projects succeed because people started with user needs, not technology capabilities. At Creed, our projects will succeed if we solve actual user problems rather than creating solutions looking for problems. If we provide user control and allow people to choose when and how to use AI, if we're clear about AI's limitations and don't overpromise, ensure human fallback options, making sure that human assistance or alternative methods are always available, and build tools with user input, involving users with disabilities in the design and development of AI tools. The rise in agentic AI makes this lesson even more important. Agentic AI creates a ripple effect, which multiplies both our successes and our mistakes. When a human makes an accessibility mistake, it affects that one interaction. When an agentic AI makes an accessibility mistake, it affects every autonomous action until someone notices. For example, say a business uses agentic AI to send out sales emails with calendar booking links. Every email goes out with the company's brand on it, but if the AI generates inaccessible content, Maybe the calendar widget doesn't work with keyboard navigation, the buttons are too small for reliable touch input, or it's incompatible with screen readers, voice controls, or eye tracking software. The company has just built a system that automatically excludes prospects with disabilities at the very first touch point. The goal was to respond faster and connect with more people. But an inaccessible booking system means you've created an efficient pipeline that filters out potential clients before you ever get to talk to them. Testing for accessibility isn't just about compliance. It can determine if your solution actually solves the user problem. It isn't optional, it's quality control. For AI to be inclusive, people with disabilities need to be included in the design and development of AI products, because if the tools work for people with disabilities, they'll work for the typical user. A basic design principle is that you should build for edge cases. Projects that work for edge cases are more robust for everyone. Comprehensive accessibility testing on every project may not be practical, but adding keyboard testing and an accessibility checklist could catch many problems. Then, for more critical applications, where one mistake affects thousands of users, we could invest in actual user testing. So to wrap up, a final question: are we creating truly accessible AI? Are we testing actual edge cases? And are we asking who can and who can't use this tool? Accessibility isn't just a compliance checkbox, it's a UX issue that will determine whether our AI projects succeed or fail. Thank you.